Hey kids, Smath here. Got a couple of more phase change calculations for you. We did 2 in the last video. We're going to do another 2 on this one. These 2 take on a different feel. These are, we know a certain amount of energy is either being put into, or in the second one, being removed from a system. And what we want to know is what state of matter is going to be present at the end of all this. So in the third example here, we have how many grams and what state of matter are going to be present when 150 grams of water at 50, so we got pretty warm water already, absorbs 50 kilojoules of energy. Well, that's why we take and we start out with our graph that's over here. It's off to the side. And that graph is telling us that if we take and start at 50 degrees and heat it up to 100, then how far down this 100 can we go? Do we have enough energy? We have this dotted line. Maybe we only make it part of the way. And if we make it part of the way, we have to determine how far did we make it. So the first step we have to do is we're going to take that 150 grams of water at 50 degrees and we're going to heat it up. Now, how come I have 50 degrees here? Well, it's really quite simple. It's going from an initial temperature of 50 degrees and the final temperature, the highest temperature you can have liquid water is 100 degrees. So it can't get any warmer than that. If that's the case, my temperature change is 50 degrees. And that's going to end up costing me 150 times 4184 times 50 degrees. That's going to cost me 31,350 joules. Remember, we had 50 kilojoules. So that's 50,000 joules we have to spend. We just spent 31,000 of them. Basically, we got about 18,500 joules, 18.6 joules to spend. Well, let's see if we can vaporize all that 150. If we're at 150 and we try to vaporize it, well, bad news. That's going to cost us about 340,000 joules of energy. We don't have that much energy. Remember, we only have 18,600. So what are we going to do? Okay, we're going to take the amount of energy that we have, find out how much energy it takes to vaporize that, and see how much mass we can vaporize. So in this case, if we solve this, 18,650 equals M 2260. M is the amount of liquid that vaporized. We vaporized 8.25. The remaining 141. How come it was 141? Because we started out with 150 grams. We were able to vaporize 8 grams of it. The other 141 is going back into liquid. It's going to stay there. And it's going to stay at 100 degrees. We're on this plateau. And we'll stay on that plateau at 100. So the answer is we have 8.25 grams of vapor or steam. We have 141 grams of liquid water, and both of those are at 100 degrees Celsius. That's a heating it up, and we had enough energy to vaporize it, and then it stopped. We ran out of energy. Can't vaporize all of it. Let's take a look at example 4. We're going to work this one out together. Okay, go there, shrink it on down a little bit. It says, how many grams and what state of matter exists when 75 kilojoules of energy is taken away from 100 grams of water, liquid water, at 95 degrees Celsius? So the first thing we're going to do is we're going to go 95 degrees to 0 degrees, and that's going to be of liquid water. And that's going to be 100 grams, 418, and our temperature change is 95 degrees Celsius. And so this is going to cost us 100 times 4.18 times 95. This is going to cost us 39,710 joules. So we have 75,000 joules over here, and we just spent 39,710. So we still have 35,290 joules. Okay, so right now we have liquid water at 0 degrees Celsius, and we are still removing energy from it. We're taking energy out. So what's going to happen when we take that next energy out? Now we're going to freeze the water to ice at 0 degrees Celsius. Now this is the heat of fusion it's going to cost us. So we have 100 grams, and that's going to cost us 334 joules per gram. Ooh, this is going to be close. Oh my gosh. 33,400 joules. So we still have a little bit of energy left to remove. 35,290 minus 33,400, we still have 1,890 joules to use. So now we're going to cool off our ice. And we're going to cool off that ice by saying, if we start with 100 grams of it, ice is 2.0 joules per gram Celsius. What's the delta T if we remove 1,890 joules? Well, the change in temperature is going to be about 9.45 degrees. But remember, we started at 0. So the final temperature is negative 945. And what states do we have? We have solid ice. I don't care if you say ice or say solid, but that's what we have. So this is a classic problem where we kept removing energy and cooling it off and cooling it off and cooling off until we find out we get a final temperature of negative 945 degrees Celsius. These are, you have a certain amount of energy, and how much do you end up with? What state of matter do you end up with when you're done with it? I'm Smath. These are phase changes. I'll see you in our next video, which should be thermostoichiometry. I hope this video helped.